Welcome back. I come to you as the great Mr. Prickett because I am going to read your mind. Mwahaha. Through the computer by all means. So here's the number game we are going to try, and I will be able to guess your symbol. Mwahaha. Yep. Choose any two-digit number. I'm going to trick 42. And it says add the two digits together. That's 6. And it says, oh, then subtract the total from your original number, which is 36. I go over, and I should see the arrow pointing to the upper right with a slash. Let's see if it worked. Wow, pretty cool game, huh? Well, why don't you try it? All right, pick a different two-digit number. Find your symbol, and I'm going to read your mind through the computer. I'm not even going to use this flash mind reader because computers are so powerful today. They might be able to read your mind. Who knows? So try it out. If you need to pause, go ahead. You got your number? Okay. I'm looking into the screen. I see ringing. Oh, I see music. I think your symbol is a bell. Am I right? Ooh, so looks like maybe there is something to this. Or I'll tell you right now, you're a bell again. I'll tell you again, now you're a sun. And it's not that I look at the same symbol every time because they'll switch. There's an actual mathematical reason of why you can do this. So as a challenge question for your homework tonight, I want to see if you can actually mathematically prove why we get the symbols we do in this game. Okay, think about using the two-digit number. You know, we've been talking a lot about evens, odds, consecutives. Think about how you can write a two-digit number and add them together and subtract it and see why we always get or how we can actually read the mind. It's actually a pretty cool little trick, mathematical. If you don't get it, that's okay, but I want you to try it. So that's our idea for today. We're going to play some number games and see if, you know, a lot of magicians are really, really good mathematicians and vice versa, and there is a little bit of mystery to these magic games, and that's what makes them fun. So I'm going to try another one. I want you to pick any integer between 0 and 20. You need your calculator, grab it quick. I want you to add 5 to that number. Multiply the result by 6, divide the result by 3, and subtract 9 from that result. Now, what's really fun is, let's say I get an outcome of 21. Maybe I get an outcome of 39. Maybe I get, I don't know, 17. I could tell you the beginning number of this one. I could tell you the beginning number of this one. I could tell you the beginning number of this one. And if you got that, watch my magic. This one started with 19. This one started with the number 8. And this one started with the number 10. So just by hearing my answers, maybe try and see how I can get that. Now, think about generalities again. It says pick a number between 0 and 20. Well, I don't like starting problems and say, well, I'm stuck with picking the number 3, and then I'm going to go through all the cases. No. What's another way we've been thinking about numbers? Well, maybe let's say, pick an integer between 0 and 10. Well, let's call it n. I don't care if it's between 0 and 10. Maybe it's 0 to 1,000,000, as long as it's an integer. Then it says add 5 to your number. Well, maybe there's an algebraic way of writing that. Why don't we get n, and we're adding 5 to it. So no matter where I start, I automatically add 5, and that'll be my result. But now it says multiply that result by 6. Ooh, we're going to put that in blue. Let's see what it would look like. Notice that I put the whole result in parentheses. And when you can, simplify as much as possible. I don't want a big, long algebraic expression if I don't need to. So this would become 6n plus 30. Okay, divide that result by 3. Turn this off quick. And what it simplifies to is we get 2n plus 10. If you guys remember, maybe I'll say this in class, this uses the heart method. Unless I have to divide that one by 3 and that by 3, and it makes it a little hard. Oh. But 6n divided by 3 is 2n. 30 divided by 3 is 10, so make sure you get both terms. And then the last step says subtract 9 from that result. So when I subtract 9, this becomes 2n plus 1. Now I had answers like 17. I think I had a 29. Okay, doesn't matter, I guess, but look at what I can do to actually find the original number. This is saying I go through all those steps, and it's going to follow whatever my n was at the beginning. I'm going to double it and add 1. So to verbally say that, or to work this backwards, let's say your friend tells me it's 17. Well, I'm going to say that their number started with 8. And what I'm doing is I'm subtracting 1 in my head. Ooh, difficult. And that's 16. And then algebraically, divide by 2, their original number was 8. So you can use this little trick on your friends and just remember that you subtract 1 and divide by 2. You know the magic. That's what the best thing about magicians are. There's just one little trick that they know compared to you, and you just look like a star. So what I want you to do is try with this one. For your homework tonight, write the algebraic expression, the simplified algebraic expression for this number game. Okay, so you're going to have an algebraic expression, show all your work, show every step. And then what I want you to do after that is I want you to explain how to get the original number. Okay, so picking a number. Start you off n. If you want to use a different number, I don't care. But I think n is the easiest. And then double it. Add 3. Multiply the result by 5. Subtract 7 from that result. After you do that, again, find the algebraic expression, simplified. Explain how to get the original value in words, like sentences, proper sentences. And you know what? I got 98. So tell me what my original number was tomorrow. Tell me my original n. Okay. The second one I'd like you to do is a little challenge one that I made up, so part of your homework. So I want you to pick a number. So I want you to add 7 to that number. Then I want you to square the result, subtract 40 from that result, and subtract 14 times the original number. That's kind of a weird step we haven't seen yet. Subtract 14 times the original n. So same thing. I want you to find an example outcome and explain the algebraic steps to find the original number. Tell me what you would have to do to go backwards. And then this is the new one for you guys. Here's my challenge. I want you to make a 5-step number game that ends with the original starting number. So if they think in their head, okay, I thought of 5. I go through 5 steps, they better get a 5 back. Now don't be cheap. Don't add 1, then subtract 1. Don't multiply by 1. Don't add 0. Okay? Have some fun algebraic expressions. This is your time to be creative. I want to see how interesting you can get with these. So again, 5 steps minimum, we'll say, and see if you can get back to the original number. Try and stay away from multiplying by 2, dividing by 2, all those even numbers, okay? Like you said, square things, square root them, see if you can deal with that algebraic expression. So that's your challenge for tonight. I hope you have some fun. Hopefully maybe show your parents the mind reading thing, see if they can figure it out, work on that, have some fun with that. And I will see you tomorrow.